Last week you wrote your first Python program. This week we're going to do something physical with our programming, and today we're going to be controlling some LEDs. We're going to start this session assuming that you have your LEDs set up and connected to your Raspberry Pi. Then, just like last week, we're going to go to the programming menu and open Python 3. We're not this week going to spend any time in the shell. Instead, we're going to go to File, New File, and create our program. Last week, we imported the time module. This week, we're going to use a different module called GPIO0, which makes controlling physical hardware nice and easy. From GPIO0, we want to import a class called an LED. And a class is just a description of how an LED should behave. And then the second line we want to write is we want to tell it where that LED is and give it a name. I'm going to use a variable name red_LED and tell it that is an LED and it's going to be on pin 17. This should correspond with the pin number that I've used to physically connect the LED to my Raspberry Pi. Next, let's run our program and see what we have working. So first of all, save it again. Ultimately, we're going to make our program blink, so I'm going to call my program blink. And if we run our program, nothing very much happens. That's because all we've done is told the Raspberry Pi that we have an LED and it is on pin 17 and we're going to call it red LED. We've not told it what to do with that. Once we have that object though, we can start to play around with it. So if we were to type in red_LED dot on, open and close parentheses, that command when we press enter should turn our LED on. The same is true if we type red_LED.off. That should turn our LED off. These two steps are really important because they allow us to test that we have control of the LED. If at this point your LED does not turn on or off, go and debug your circuit and check you have the LED the correct way round. To make our LED start blinking, we need to add two things to our program. The first is we need to import an extra function. So from time, we're going to import sleep, just like we did last week. And secondly, we're going to need a loop to make our light flash on and then off again. A loop is a structure common to most programming languages, and in this case, we're going to use an infinite loop called a while loop. If we write the line while true, this will make Python loop round forever, and every line inside the loop is indented. Let's start with a red_LED.on. This will make our light come on. We're then going to add a pause in using the sleep command, and I'm going to go for 1 second. We're then going to turn our LED off, and after that we're going to make it sleep again for 1 second. And there we go, that's our blinking program. If we're now to run our program, it will ask us to save again. Our program is now running and we should see our LED blinking on, off, on, off. Fantastic. It may not feel like much, but you've just created something that controls a physical object using code. And this is a really important moment in stepping from the virtual realm into the physical realm with your programming. So these 5 highlighted lines of code can be written in a slightly shorter form. Instead of specifying whether the LEDs turn on or off or when they sleep, we can think about the function as a whole. This function is making the LED blink. The LED class includes a function called blink and can be used to replace these 5 instructions. When we open a parentheses, we can see the 4 options we can give it. The on time, how long the LED turns on for, the off time, how long it's off, N is the number of times the blink repeats, and background is whether this occurs behind the scenes or whether the program waits for it before continuing. If we just use a closed parentheses, we are specifying the default options, which is to make it on for a second, off for a second, infinitely, and in the background. However, If we were to write this with some other parameters such as 0.1 for the on time and 0.2 say for the off time, this would flash the LED on for 1/10 of a second and off for 2/10 of a second infinitely. If we were to include a third parameter, and so we said 0.2 for the on time, 0.1 for the off time, and then 5, this would flash the LED on and off 5 times. Within GPIO 0, there are a number of other really useful functions that make working with LEDs and other components much easier. We're going to briefly explore a few of those now. So firstly, there's a built-in function called toggle. If I type red_LED.toggle, what this will do is it will turn the LED on if it's already off and off if it's already on, inverting the state of the LED. Now this may not seem revolutionary, but what it allows you to do is not have to care about what the state of the LED is, just toggle it. If I then add a sleep in of a second, I could then also ask Python what the state of the LED was. So I can print out a message, and I can get that message by saying red_LED.is_lit. And if I were to run that program, it would tell me whether the LED was lit or not. I'm going to copy those 3 lines and paste them below. And if I run my program, what I would see is my LED will flash on and then flash off. And it will tell me that the LED was true and then was false. If I were to take those 6 lines and wrap them up inside a loop, I would have my blinking program, albeit in a longer form. This point is really important. There are many ways to achieve the same goal, and none of them are correct or incorrect. They are just different. Get your LEDs blinking